Okay, let's do problem 142, linked list cycle 2. So it's exactly same as linked list cycle 1, problem 141, except this time we need to give the starting point of the cycle. So we're going to do the exactly same thing as the linked list cycle 1. So we need list slow equals head, and then list node fast equals head again. And then while fast is not equal to null, and then fast is not next is not equal to null, we're going to do slow equals slow dot next, and then fast equals fast dot next. And if slow equals fast, that's when they meet. So just to draw a diagram, that's where they meet, and then that's the entry point of the cycle, and then that's the starting point. So at this point, slow and fast will both be here, but we are going to create two pointers. So there will be one pointer here at the start, and then there will be another pointer here where they met. And then we are going to iterate them one by one until they meet. And surprisingly, they meet at the entry point. And we'll go through the logic later. So we're going to create P1, which is equal to head, and then list node P2, which is going to be slow, where the slow is. And then while P1 is not equal to P2, we're going to do P1 equals P1 dot next, and then P2 equals P2 dot next. And then return P1 or P2. And there could be a case where there's no cycle at all. So we're going to return null because we have to return something. And if there's only one cycle, one node in linked list, there's no cycle. So the way we detect this one is if head.next is equal to null. And then there could also be a case where head is also null. In this case, we return null. Let's run the test. Okay, let's submit. Okay. So it's time to prove why we how we know when P1 starts and P2 starts each point, and then when they meet, it's the entry point. So I think it's fairly mathematical because we'll see. So suppose the distance from start to entry is x, and then entry to where they met is y, and then the length of the full cycle is z. So when slow entered entry, no matter where fast is in the cycle, it will catch up to it at this point here. Well, it's not an arbitrary point, but what I'm saying is slow couldn't have possibly did a full loop and then met fast here. It's just not possible. And so we do know that slow moved x plus y amount in total, and then fast moved twice as much because that's how we set it. But another way of looking at the distance of fast is fast moved x plus y and then did some number of full cycles. So to write that down, we can say that fast moved 2x plus 2y. We said it also moved x plus y and then n number of cycles. So where n is an integer, so the number of full cycles it did. We're not interested in n. So if we were to tidy up, we get x plus y is equal to m minus z, and then x is y, n times z, sorry, nz, and then it will be nz minus y. So we had pointer 1 here and then pointer 2 here. So by the time pointer 1 moved x amount, pointer 2 would have also moved x amount because we're incrementing by 1 for each. So when x gets here, pointer moved x, but also it would have moved n number of full cycles minus y. So if you do n number of full cycles, no matter how many cycles you do, you're going to stop here. That's the end of the cycle. And then if you do minus y, that's the entry point. And that's the logic behind it.